pulmonary circulation. Again, this is the blood flow from the heart to the lungs. So again, leaving the right ventricle, going through the pulmonary semilunar valve, pulmonary trunk, pulmonary arteries right and left, lobar arteries right and left, lungs, lobar veins, pulmonary veins back into the left atrium, which we know all about because it was on practical 1. Look at that, it's like pulmonary circulation. Systemic circulation, flow from the heart to the body and back. So from the left ventricle through the aortic semilunar valve to the ascending aorta, the aortic arch, all the different divisions back to the inferior, superior vena cava, and eventually into the right atria, which we should know all about because there's like a quiz today in lab over there. Oh, there he is. Little jazz hands man. He looks like he's very happy to show you his vessels. Look. Some special circulation, again, the hepatic portal circulation. This is the flow of blood from the stomach, the small and large intestines, the spleen, the pancreas, the gallbladder, all going to the liver for filtering, processing before it goes out into the world. Okay, so this is how we don't have sugar highs or sugar lows unless you have an insulin problem. We don't have protein highs or protein lows because we have the hepatic portal circulation. So as we're digesting food, the nutrients we are absorbing, the proteins we are absorbing, and the carbohydrates we are absorbing, they're going to go into the hepatic portal circulation and then go to the liver. And the liver is going to store the sugar, the liver is going to store the protein, it's going to process. That way, if it's been 5 hours since your last meal, the liver can start releasing sugar so we don't drop. We can release protein as necessary. So our sugar levels in the blood should be fairly constant. Our protein levels in the blood should be fairly constant. Now, of course, while this blood is going through the sorting and storing process, we'll also filter it. So if a bacteria try to sneak in from your digestive system, the liver will kill it. So again, there's no need to have a cleanse. That's the job of the liver, right? There's no need to eat fancy yogurt. That's the job of the liver. The body does those jobs. They just try to sell you stuff so you don't pay too much money for yogurt, okay? Or cleanses or whatever else the body does on a natural basis. Okay. And again, this is why we don't have sugar highs, sugar lows, protein highs, protein lows. You'll notice they don't absorb fat. So when we look at the overall health of people usually complain about high cholesterol levels in their bloodstream because it's not being put through the hepatic portal circulation. It's not being stored and processed like the proteins and sugars do. So that's the inherent reason why fat causes problems. It's not because it's bad. It's because it doesn't go through the system. It doesn't get stored and sorted like we do the other nutrients. So we do have the highs and the lows depending on what you eat. We'll get into how we get that into the system. Look at that, it's like the hepatic portal circulation. So again, you've got the inferior mesenteric vein is going to join up with the splenic vein. Then we have the superior mesenteric, those splenic and the superior mesenteric join to form the hepatic portal vein. And then the gastric vein swoops in after it's already been made. And then we go to the liver for the sorting and the storing. And after that blood is sorted, stored, processed, filtered, what have you, then we go into the hepatic veins and then join into the inferior vena cava. But we already knew all that. Maybe. All right, the circles of what you talking about, Willis? All right, if you never watched Different Strokes, shame on you. I guess it could be the circle of Bruce Willis. Makes you happy. Okay, so the circle of Willis, it is a circle. It's kind of like a roundabout, which is fairly annoying whenever you run into those things, right? All right, it's going to do the same thing a roundabout does. If this street is blocked, you just keep going around until you get to a good exit point. So that circle of Willis is a circulatory pattern at the base of the brain that ensures adequate cerebral circulation. So if we have a partial blockage here, we don't immediately have a stroke and death. We can just go through the back way. We just keep circling to go up through that vessel through a back door. So that circle of Willis is going to help ensure proper and adequate blood reaching the cerebrum so we don't have a stroke, so we don't die. So there's our circle of Willis. It is actually a circle. Okay? So that blood is going to come up through the vertebral arteries that join to form the basilar arteries. Some people say basilar. It's the same people that say basil versus basil if they're cooking. English folk, that's who the problem is. Okay, so then they hit that circle of Willis. If we had a blockage right here, we don't have to worry about no blood getting to this big vessel. We can just come around the back way and get to that big So that's the circle of Willis. It does look like a little person. Do y'all see the little person? Like a little head, little body, little arms and legs. He's adorable. It's Willis, okay? And making sure you get blood going to your brain. Fetal circulations, because babies be weird, right? Yes, babies are weird. Okay, so what's the biggest difference between you and a baby? Don't say size. Okay, they're getting nutrients from mom. What else? What's the biggest thing? No, they're inside. They haven't done that yet.
Oh.
Yeah, internal babies.
They have more what are they called?
Oh, it's hitting all around. What's the big difference between you and the baby on the inside? Not the umbilical cord. I thought I heard a word say before that.
They're in the sack, or
Okay.
they're breathing liquid.
No,
Or they're not breathing.
they're not breathing at all. Babies don't breathe. They don't have a snorkel. That would be creepy. And then you wouldn't be able to take a bath because a snorkel wouldn't work underwater. So where's baby getting all their oxygen?
From Madre.
Mom, sucking the life right out of her, nutrients, oxygen, and all. So instead of having the lungs as the exchange for oxygen and carbon dioxide, we're going to have the placenta as the exchange of oxygen and carbon dioxide. So that means their circulatory system kind of starts and stops at a different location. Oxygen levels are going to be different, all because their lungs don't work. The lungs are the only organ that doesn't work until the day you're born. And then you take your first breath. Everything else is working. So if you have a third term fetus, it's dreaming, it's hiccuping, it's hitting the inside of your ribs. It's doing everything babies do except breathe. Okay, so they're able to do all that because they're coming, getting all that nutrients, all that fun stuff from mom. The breathing is the last thing that happens because they have to be out in the air in order to breathe. So because we have a different drop off and pickup point for oxygen and carbon dioxide, it shifts oxygenated, deoxygenated blood locations. And of course, we have to have that circulatory system to hook up to mom so we can suck the life out of her. So the umbilical arteries, there's two of them. There's a pair of umbilical arteries, and they're extensions off of the internal iliac arteries, which I find really weird personally because it's like they're crotch arteries that have to come off and then come out your belly button. It's like, why not something closer to the belly button? That would make sense, but no, coming from down there, loop up, and then go out. It actually wraps around the outside of the umbilical vein. So it's kind of like when you see a candy cane. The candy cane's white with the painted on red swirls. Okay, same thing. The umbilical arteries wrap around the single umbilical vein. So they kind of twisty around that little guy. So the umbilical arteries carry the crappiest blood. It's the carbon dioxide filled, the least amount of oxygen, the most amount of waste. It's going to the placenta to drop all that waste off for mom to have. So it has the bluest blood if we were coloring it on the schematic there. So it's going to have your most deoxygenated blood. After you're born, you cut off your umbilical cord. That's going to cause it to vasoconstrict shut very quickly because, it becomes a stub. And it will become what's called the medial umbilical ligament. So these are ligaments that you can find within the body cavity. Now the umbilical vein, again, it's a vein because it's going back towards the heart, not because of the content. The umbilical vein has the bestest blood. It's coming from the placenta, so it's the most oxygenated, it's the most nutrient-rich blood coming back to the baby. And again, we just have one umbilical vein, two umbilical arteries. So once it comes into the belly button, once it comes into the umbilicus, you're going to have one duct that goes straight to the liver. You're going to have one duct that goes straight into the inferior vena cava. We'll get that to a minute. So that one going to the liver is going to join the hepatic portal vein so the baby can pretend they're filtering, kind of like you buy your kid either a plastic lawnmower or a plastic vacuum and they can pretend they're mowing the lawn and doing vacuuming. It's like, here, pretend to do chores you're going to have to do for the rest of your life. Good. At least the bubble blowers had bubbles, right? Bubble blower. All right, so that little guy helps the baby's liver to start storing some sugar in case mom's not eating. What do we say? Mom's always eating, she's pregnant. But we do store some sugar, some protein in case we need it. We start doing our filtering processes. The other one that doesn't go to the liver goes straight to the inferior vena cava. That's our ductus venosus. And of course, after we're born, we cut the umbilical cord. It's going to venoconstrict shut, becoming the round ligament of the liver, which we will see on practical 3 in the liver on the liver models. This is, again, the only fetal vessel that has fully oxygenated blood. Once we hit the belly button, we're going to start distributing oxygen to the body. So we're going to get less and less red, more and more purple whenever we look at the distribution color mapping. The placenta. So the placenta is an organ that attaches to the wall of the uterus. So it embeds itself into the endometrial lining. And it works as an indirect connection to mom. So there is no touching of fetal and maternal blood. What we have is in the uterine wall, we have lots of capillary beds. In the placenta, we have lots of capillary beds, and they're parked right next to each other. And because the fetal blood has more carbon dioxide, more waste, they're going to diffuse from and through the placenta into the maternal bloodstream. Mom has more oxygen, more nutrients, so they're going to diffuse through the placenta into the fetal bloodstream. So an indirect connection to exchange with mom. So no mixing of mom and baby blood. The ductus venosus, again, that's that umbilical vein branch that bypasses the liver, goes straight into the inferior vena cava so we can circulate it throughout the body. And of course start delivering oxygen and nutrients to the body tissues. After birth, it's going to venoconstrict because you cut the umbilical cord, everything attached to that shrivels up. It venoconstricts and becomes a fibrous cord called the ligamentum venosum, also associated with the liver. Our next set of bypass. So we've got liver bypass because the liver's not doing full work. Now we're going to have a lung bypass because, again, they're the only organ in the entire fetus that is not working until you pop out and take your first breath. And again, this is that difference between is the baby alive or baby dead, or is it a baby legally or not legally, right? That's why third-term abortions keep the head in, because if they take a breath, they can't kill the baby. It's murder. So that's why a lot of people don't like third-term abortions, because everything's working except for the lungs. If they take a breath, their baby, they can't legally kill it.
That is horrible.
It is horrible.
Oh my God.
It's in there. All they do is go and scoop out the brain, killing the baby. Terrifying. So anyway, since the lungs aren't working, we don't need to go to the lungs. Okay, so we can bypass them. So we have 2 different bypasses going from the heart, so we can bypass the lungs, go to the systemic circuit. So we have the foramen ovale. This again is why we don't Google things, because the term foramen ovale just means oval hole. If you remember in A&P1, there's a foramen ovale in the skull. I didn't make people know it because it's just an oval hole. But if you put a hole in the skull, they'd be like, no, stupid. Foramen ovale is in the blood vessels because we're in the blood vessel realm. Again, a lot of times we reuse, like macula, you reuse that word a lot because it's just Latin. So you have to have it in the right context. So if I ask what is the foramen ovale, this is A&P2, I don't want a round hole in the skull. I want the opening between that acts as a bypass of the lung. So in between the right atrium and the left atrium. Okay, so context clues kind of scenario. So what happens again, blood comes into the right atrium, goes through the foramen ovale into the left atrium, left ventricle, back out to the body. So completely bypassing those lungs. After birth, with the openings, the bypasses here, there's no urge to close immediately, right? You don't cut something off and it shrivels and falls off. So this one usually gradually closes over time. It takes about 2 months for both of these bypasses to completely go away. And that's why during the first couple of months, babies aren't as active as they are later, because they don't have as much oxygenated blood distributing like they're supposed to. They're running on half tanks, so to speak. So by hopefully that second month, this has completely closed up. So it's going to decrease in size and eventually close, leaving a little depression called the fossa ovalis. So the oval hole becomes an oval dent in the heart. So it's right by that coronary sinus. The ductus arteriosus, we don't want to completely stop blood from going through the right ventricle because it needs to pretend it's doing work too. So some of the blood that doesn't go through the foramen ovale goes into the right ventricle, goes up through the pulmonary semilunar valve to the pulmonary trunk, and then takes a U-turn at the ductus arteriosus, goes straight to the aorta and then out. So also bypassing the lungs. After birth, it should also vasoconstrict, takes a little while, about 2 months, and becomes the ligamentum arteriosum, which becomes just a little piece of flesh connecting the aorta and the pulmonary trunk. So it acts as an anchor point between those two. So this should be completed during the 2nd month, and everything's up and going, and the baby can, do its thing. There's a baby. So again, full term versus